Continuous random variable. Now let us talk about continuous random variables. So suppose there is a department, an army department, let's say, and it is asking, there is a rule that all the army officers, they should have weight between 150 pounds and 250 pounds. So this is a continuous variable. So for any particular army officer, he can have any weight, right, between 150 to 250 pounds, right? So this is what the continuous random variable would mean. So continuous random variable can take up any numerical value in an interval, very loosely speaking. Please write continuous random variable can take any numerical value in an interval, right? So a continuous random variable is going to be a set of the possible values which are defined over an interval, right? And is characterized by the uncountable infinite values, right, within that interval. Let me just write few points and I'll give you more examples. A continuous random variable is a set of possible values so which consist of an entire interval, right? On a number line and is characterized by infinitely uncountable values within an interval. It's characterized by infinitely uncountable values within any interval. So for example, I've just given an example. For example, the weights of individual, they can vary between 150 to 250. So they can take up any values. That's a continuous random variable. When you write about the probability distribution function, or the probability distribution function. So for any random variable, the probability distribution function is going to list the all possible outcomes of that experiment and the probability which is associated with each of these outcomes over the sample space. So please write the probability. We have given an example of this in the earlier recordings also. For example, you toss a coin, and so what is the probability of appearing two heads? Suppose you toss two coins. So what is the and the outcome, the random variable, is the number of heads. So they can appear two times, one time, no time. So these are the different outcomes. And what is the probability associated with each of these outcomes? So that is what the probability distribution is. The probability distribution of a random variable is a list of all possible outcomes of some experiment and the probability associated with each outcome in a given sample space S, let's say. So the total probability is 1, right? So that is what the probability is. And this is telling you that how is that probability of 1 going to be distributed among the different outcomes? We have seen that example also. So if X is a random variable, is that the formal definition? If X is a continuous random variable, then Fx, which is describing the probability of X, is called a PDF of X, probability distribution function of X. And 2 points that, of course, this has to lie between 0 to 1, this probability. And you can, of course, you can also write it like this, that the sum of the probabilities that also has to be equal to 1. So sum of probability from minus infinity to plus infinity is 1, right? So that is what it is. That is equal to 1. Now, the area under the curve is given by the different function that is called the cumulative distribution function. So cumulative distribution function is used to evaluate the area under the curve. So mathematically speaking, cumulative distribution function is an integral over the probability distribution function between the two values, right, of the continuous random variable. So just let me just write it, then I'll give an example. The cumulative distribution function is the integral over probability distribution function and the probability between the two values of a continuous random variable will be the integral of the PDF between these two values. And that is what the area of the curve, area under the curve between these two values. So area between so area under the entire curve, that is going to be equal to 1, right? So for all possible values of the random variable, that is going to be equal to 1. So the few things which we should understand for the continuous random variable, the outcomes are measured, they're not counted. So in case of discrete random variable, we are counting the outcomes. So here we are measuring them. Outcomes are measured and not counted, right? The other thing is that the entire area above the x-axis and under the curve is equal to 1. So that is what the probability is. So that is the probability of all the possible values, right? So that is the total probability which you have. The entire area under the curve and above the x-axis is equal to 1. And above the x-axis is equal to 1. So let us just take up an example. So consider a function. Consider a function fx is equal to 1 upon 20. Or 0 is less than x is less than equal to 20. Like this. So x is a real number. So you're defining this way. So you're saying this is x, this is fx, and fx equals to 1 upon 20 is this. That is just a horizontal line. Y is equal to 1 upon 20. And here you have x is equal to 0, and here let's say you have x is equal to 20. Here you have x is equal to 20. So the area under the entire curve, the area is going to be what? This is going to be the width and this is the height. So area is base into height. What is the base? 20 minus 0. What is the height of this? 1 upon 20, so that is equal to 1. So this is what is meant by the area under the curve and the above axis is equal to 1. So that is what it is. Then the next point is probability is found for the x intervals, for the x values. Please write. Probability is found for intervals of x values for the continuous random variable. So we are not finding out the probability that x is equal to this particular point. We are finding out what is the probability that x can lie between these 2 points. So that is the difference between the discrete and the continuous case. So probability I have written it also. That is, for a continuous probability distribution, the area is equal to the probability. If you want to write it, you can just write it somewhere. For continuous probability distribution, probability is equal to area, right? So probability is found for intervals of x values. Rather than for individual x values. So if you remember, in our earlier recordings, we talked about this guy, for example, in toss of two coins, the you're listing the number of heads which are appearing. So x could be 0, x could be 1, x could be 2. So we are finding out the probability of the individual x value. What is the probability when x is equal to 2? That is, you will have two heads in the two tosses of coin. But what we are finding out in case of the continuous variable is between the cases, that is between for the interval, right? Instead of for the individual x values. So for example, let me write the second point also, then I'll give you what I mean by this. So when we write the probability of x lying between C and D, it is the probability that the random variable x is in the interval CD. So it is the area under the curve, of course, above the x-axis, right to the C and left to the D. That is what it is. Is the probability that the random variable x is in the interval between the values C and D, right? So when you say like this, I mean, you're saying you have to find out the area under the curve above the x-axis, which is to the right of C and left of the D. So for example, in the example which you have taken, suppose we want to find out the probability that x is lying between 0 to 2. Suppose we want to find out the probability that x is lying between 0 to 2. So you have x here, you have fx here, you have, this is 1 upon 20. This guy is x equals to 20. And here you have 2. And here you have 0. So this is the area which we need to find out, right? So that is what is meant by this. So here in this case, the area is going to be base into height. Height is what? 1 upon 20. Base is what? 2 minus 0. So this is going to be 1 upon 10. This is going to be 1 upon 10. So the probability is 0.1. So the probability is 0.1. Now, if we say that we want to find out the probability of one particular value, now that probability in case of the continuous random variable, that is going to be equal to 0. So x equals to c is equal to 0. So the probability that x is going to take up a single value, that probability is 0. So the probability that x takes on any single value is 0, right? So when you draw the curve, so for example, if I need to find out x is equal to 15, what is the probability that x is going to be equal to 15? Is x out here? This is 1 upon 20. And I say, I need to find out that the probability is 15. No, here the probability means the area. So what is going to be the probability for x equals to 15? That is base into height. But x equals to 15 is just a vertical line. It has no width on its own. So that base is equal to 0. Height is 1 upon 20. So that is coming out to be 0. So that is what is meant by this. So these are few points for your continuous random variable, right? Okay. Thank you, Beta.